Welcome to the TI DLP Pico product selection training. The objective of this training is to select a Pico chipset based on an application's display requirements. This training is targeted for product developers. Let's get going. In this training, we will cover 4 topics. The first one is display selection. These sections outlines the variables that need to be considered to select a chipset. The second one is Pico digital micromirror device portfolio. In this section, we will cover all the display devices covered by the DLP Pico portfolio. Then we will transition to the Pico display subsystem, and in this section we will cover the Pico display subsystem block diagram, including product selection of the display controller and power management devices. And then finally, we will briefly highlight key resources for evaluation and development of Pico display subsystems. So you are wondering how to use this video. Well, this video is split up in various sections. You do have the option to skip to any section by fast forwarding the video and paying attention to the hexagons on the top right. Each color represents a section. Now let's get started with section 1 called display selection. For display selection, there are 3 variables to consider. The first one is going to be the resolution of the display. The second one is going to be the brightness of the display, and the third one is going to be the image distance from the application to the display. So let's go ahead and look at each one individually. So for resolution, there are a few variables to consider. The first one is market standards. And the reason why this is important is because for some markets like personal electronics, key specs from an end equipment such as Full HD or HD are critical for the end customer to purchase the product. The second variable to consider is display size versus resolution density. And the reason why this is important is that you want to make sure that whatever your display, either video, graphics, or whatever have you, is displayed properly without any sort of a screen door appearance. And the third variable is going to be how much video and graphics content you're going to have in your application. So for example, if you're going to have very detailed graphics, you may require higher resolution than if you're just going to display general video. So it all depends, at the end it's all going to depend on the application, and you probably have to look at different scenarios and sizes to finally make your resolution decision. Now let's look at brightness. For brightness, there are a couple of considerations to think about. First of all, you have the image size, and so for a larger image, you will require more brightness. Secondly, you'll have to think about the ambient light conditions. Obviously, if you're in a dark room, you're going to require very little brightness versus if you are in a living room or even outside, you're going to require more brightness. And then finally, you also have to consider the digital micromirror device size, as this will also determine how much brightness you can afford. And so these are the 3 considerations for brightness. Given all these trade-offs, we actually have published an application note that highlights all these different conditions that we just discussed. And to be able to look at this, we strongly recommend you go to this application note called brightness trade-offs, and you can learn more about it at ti.com/DLP Bright. Now that we have covered resolution and brightness, let's jump over to image distance. The image distance is going to be the distance between the end product and the display. In the industry, there is a ratio called throw ratio. The throw ratio is going to be the relationship between the end product distance and the image and the horizontal image distance. Let's look at this example. For this example, we have a distance of 60 inches from the end product to the image, and we have a distance of 50 inches for the image horizontal. In this case, the throw ratio is going to be 1.2, which is 60 inches divided by 50 inches. So for different numbers or values of throw ratios, there are a couple of common terms that are used as well. The first one is called standard throw, and standard throw is when the image is going to be quite far away from the end product. Typical throw ratio values are going to be over 1, and this means that the distance between the end product and the image is going to be larger than the horizontal distance of the image itself. Then the other two terms are going to be ultra short throw and short throw. For ultra short throw, these are when the end product is extremely close to the image itself, and the throw ratio values can be as low as 0.2 and probably as high as 0.4. And then for short throw, again, is when the end product is close to the image, but not as close as on the ultra short throw situation. And for these numbers, we see values between 0.4 and upwards to 0.9. So that is it. Now we have finally been able to see 3 considerations that you want to think through. And the first one is image distance, the second one is brightness, and the third one is resolution. Now let's take this learning to a real world example. In this video, we're showing an application for a smart home display. And now what we're gonna do is we're gonna look at each variable and determine what are the best options. So to look at our variables for this display, let's start with resolution. Obviously the display size for this is probably less than 10 inches, and so a resolution of QHD, wide VGA, even NHD may be adequate, given that we're only using graphs and symbols. So in general, a low resolution is probably required for this display. Second, for the brightness, given that the display is small, 10 inches, and that the application is going to be used for indoor purposes, we're probably going to be okay with 30 to 50 lumens for this application. And then finally, because we want to integrate this to the wall and we want to make the application or the end equipment as close as possible to the wall, we definitely will require an ultra short throw projection for this application. Now that we have the resolution, let's go to ti.com DLP and let's go ahead and select the desired DMD. So first we go to ti.com/DLP and then we select Pico chipsets. After that we go to products, and this opens up a list of categories that you can discuss. Because we know the resolution, we go ahead and select NHD, wide VGA, and QHD. After that, and after we filter all these items, we also go ahead and select DMD so that we only get DMD results. And so the resulting devices are the DLP 2000, the DLP 2010, and the DLP 230GP. At the end, when we click on one, in this case we click on the DLP 230GP, we actually can look at the details of that device. And then after that, if you click one more time, then you can go off and look at the datasheet. Now we're ready to look at the Pico block diagram. First off, we're gonna look at the DLP components, and these are the display controller, the PMIC, which is responsible for power management of the display controller itself, the DMD, and then the LEDs. And then obviously we have the DMD. In the block diagram, you also have other components, and these are the application processor responsible of communicating with the display controller, system power to provide power to the entire system, flash memory, and also RGB LEDs that illuminate the DMD. Now let's take a look at the display subsystem block diagram holistically. To your left, you have all the electronics portion, and these will include the display controller and the power management devices of the DLP components. As an example, let's take the DLP 3010 DMD, which supports the 0.3-inch 720p. It is paired with a display controller, and in these cases we have two devices, one supporting 7x7mm package and then the other one supporting 13x13mm package. The DMD and the display controller are then paired with a specific PMIC depending on the maximum current of the LED drive. So in this case we have components that range from the DLPA 2000, which support a maximum current of 0.75 amps, up to the DLPA 3005, which supports currents up to 16 amps. Please be noted that the LED current that is supported has to meet the thermal specifications of the DMD. Now that we have covered the electronics portion, let's start switching over and let's talk briefly about the cables. And so the cables are in the system to communicate between the electronics and the DMD, which is going to be housed in an optical module. The cables sometimes include a flash memory, and sometimes this is included from optical module vendors. And also you will require a cable to be able to drive the LEDs on the optical module itself. Finally, let's look at the optical module. So in this portion of the optical module, we're going to have the DMD and then the LEDs housed with optics to be including illumination optics and projection optics to be able to display the image on the wall. Last but not least, let's look at the different signals that are connected between each device. So first we have I2C and video that is between the application processor and the display controller. The I2C serves as control for the DMD, and the video signal is the video signal that is being entered to the display controller, typically as RGB parallel interface. Then we have from the flash SPI communication to be able to communicate between the flash itself and the display controller. Same situation goes for the PMIC, where we are using an SPI interface. And then for the communication with the DMD, we're using a sub LVDS, and that goes between the display controller and the DMD. So now that we have looked at the block diagram, let's transition to the DMD portfolio. And To get a good idea of the portfolio itself, let's start by defining the two axes. The first one is the brightness axis. So it goes from literally 0 lumens upward to 1500 lumens. And then the second axis on the horizontal is the resolution. That goes from NHD up to 4K. Now, we have products that that are in different categories of brightness. So what you will find first is you have sub 200 lumen products, and that range between NHD and wide XGA or 720p. And then we have products that can get to up to 500 lumens, and these are for 720p and 1080p. And then finally, up to 1500 lumens, we also have products covering a range between wide XGA, 1080p, and 4K. As noted earlier, each product, each DMD, will have a specific display controller. And as you can see above, each one has been highlighted by each DMD. Given that we have three clear positions, allows customers to have various resolution positions for each brightness category. Similarly, PMICs are also paired with a DLP chipset. And for this case, you can see that a DMD may have multiple PMICs that are paired with it depending on the maximum current of the LEDs. Finally, let's look at evaluation and development of DLP chipsets. And obviously, TI has a wide variety of resources to support development evaluation. For evaluation purpose, TI offers EVMs that can be used in a variety of ways. If somebody's just looking for a quick evaluation at a very affordable price point, then someone can look at the DLP 2000 EVM, which sells for $99 and supports a 0.2 NHD resolution. Beyond that, other EVMs are offered at ti.com, and these other EVMs include HDMI plug-and-play capability, as well as a PC-based user interface. With these EVMs, you can also configure the I2C, which includes image manipulation, IntelliBright, brightness control of the LEDs, and other functionalities. And finally, for evaluation, you can always go to the E2E community, where there is definitely somebody either from TI or from the community itself that can answer your questions. Now, when you transition to development, then there are also a wide variety of resources. On the electronic side, TI.com offers TI design resources and technical documents. As you've seen in the past, we've talked about a few of them. And then also there are system integrators that can actually work on the electronics if you choose to do so that way. On the optic sides, there are optical modules that are mass production ready, and these can be looked at ti.com. And then you also have companies that are willing to do custom optics design to cover this portion. All in all, there's a wide variety of resources for evaluation and development of DLP Pico display solutions. All right, so this is the end of the video. Now let's go ahead and look at a quick summary. And we are discussing selection of DLP Pico chipsets based on your portfolio, based on your display needs. So first, what you want to do is on your display selection, you want to look at image distance, resolution, and brightness to be able to determine what DMD, what digital micromirror device works for you. Then you want to look at the DMD portfolio itself, and then for that you can actually go to ti.com and you can filter parameters, for example, for resolution and for other parameters that may serve you. And then secondly, you will be able to see their Pico chipsets, which are the display controller and the PMIC that goes with the DMD. And obviously all this information is at ti.com/DLP. And then we go to the display subsystem, where we kind of do a quick deep dive of the block diagram. And the block diagram itself has the display controller, the PMIC, the interface cable, and the optical module. And for the electronics, obviously it's a display controller, PMIC, and for the optics, it's going to be the optical module. And then finally, we go for evaluation and development, where TI offers a wide variety of resources between evaluation modules, EVMs, E2E community, TI designs, technical documentation resources, as well as optical module makers and optical modules that are mass production ready, and as well as system integrators. Now you should be set on selecting the right DLP Pico chipset for your display application. You can also find more information at ti.com/DLP to learn more products, as well as go to your browser and type in the right DMD that you're looking for example, DLP 2010, and that will take you directly to the product folder. And if you need more information on how to get started, you can always go to ti.com/getting started. And also you can look at more DLP Pico display applications at ti.com/Pico applications. And finally, if you want to learn more about other components that TI has to offer, you can go to ti.com. All right, well, thank you so much for your time and good luck with your project.